Okay, so for FRQ 6, first I'm going to make a new g, because now it's on an inclined plane, so I'll call it gy. In this case, using that, it will be g sine of phi. That will be my new gy I'll be using for most of my equations. So for part A, 6a, so I know the H max formula is going to be initial v squared times sine squared theta over 2gy. Now I know my new gy is just going to be v initial sine squared theta over 2g sine of phi. And this will be my new H formula. And then for the next one, for 6b, what we do is I'm going to set up my speed for, so s is equal to distance over time. This distance and speed is regarding the plane at hand. And then, so I know that t, I make this sx just to show that to the horizontal. Now I'm going to move this t over, so t equals d. I'm going to put this sx and put it in the denominator, so d over sx. Now my t, because my sx is going to be initial horizontal, and since horizontal speed, and since it's a constant, it won't fluctuate. Now my horizontal speed will be d over initial speed times cosine of theta. And this will be my time it will take for it to travel across. For the next one, for 6c, I write the formula. A is equal to change in Vy over t. My A here will be g, but I'm going to put as negative g, gy, and then my change velocity will be Vfy minus Viy. And so I know that's why I'm going to all over t. So I'm going to move this t over here and then divide by negative g over y. So it will look like this. T is equal to Vfy minus Viy over negative g. Next up, this Vfy, once this stops, this Vfy will be equal to 0, and then minus Vi. So I'm going to put V0, but we're going to go to this is going to be initial, so it will be V0 of sine of theta. And then this gy is going to become, so it will be negative g sine of phi. That could cancel out the minus signs here. And then my new t will be just v initial sine theta over g sine of phi. And then for 6d, so we'll say this here is going to be changing tm. That'll be equal to what we have here, so v initial sine of theta over g sine of phi. So now the time it would take to hit the target, so we're saying it's level with the initial starting point. That means this is the time it takes to go all the way up, high as it could be. And if it goes perfectly in a perfect arc towards it, then this time, which is the time it would take to go back down, will be the same here. So the total flight time, so we have tm, so let's put t total is equal to change in tm, which is the initial, plus change in tm, which is the time of descent, times my t total to reach this will be 2 change in tm. I can rewrite t total, I'm going to move over here, as 2v initial v sine theta over g sine phi. And this will be my t total just to reach the target. Next part, I'm going to write out my range function. So then I'm going to put as d, which will the distance it takes just to reach the target. And since it's level with the target, I'm going to use the range formula. So v initial v squared sine 2 theta over gy, because this is still on the incline. Now I can expand this out as, so I'm going to rewrite this sine 2y over g sine phi. Now I'm going to isolate for theta here. So I'm going to isolate for the sine 2 theta. I'm going to multiply g sine phi and divide by initial v squared. So we have d g sine phi over initial v squared is equal to sine 2 theta. Now I'm going to inverse sine, so it'll be 2 theta, the inverse sine of dg sine phi over the initial velocity squared. Then I can just divide by 2 to get theta is equal to arc sine of dg sine phi over initial v squared. This whole arc sine is divided by 2, and that will be my theta. For part F, I'm going to be looking back at my old formula over here for h. So h in this case, we wrote earlier, is initial v squared sine squared theta over g sine phi. Over 2g sine phi, my bad. And then then if we increase, if only this theta this phi is increased, what will happen is that because sine increases as phi increases, therefore this denominator will get bigger. And because this denominator, so we say this theta, so we 2g sine phi, and we find nu, and since phi nu is going to be greater than phi initial, this instead will become less than our original. Because when you increase the denominator, what happens is that the whole entire value will decrease because you're dividing by a larger value. So as a result, increasing phi would change my answer as then this h would be smaller because of the angle increase.